Hi, it's great to have Sourav Basu with us for this follow-up video. Sourav works at Realization, the project scheduling and controlling software company that Sanjeev Gupta founded and is the CEO of. So welcome, Sourav.
Thanks a lot. Pleasure being here.
So Sourav's joining us from India, and what it will demonstrate is how the ideas of flow-based scheduling that Sanjeev shared with us are implemented in their particular software. So how software can be used at projects of scale to help and support implement the ideas that Sanjeev shared with us. So without further ado, over to you, Sourav, to kick us off and get us into the topic for this morning.
Sure. Thanks a lot, Ian. So I'll start with a slide on where Sanjeev finished it. So to give a context as to how exactly the software should work, and then basically take you through an example in the software to show who it actually does it and what sort of signals and how the control comes for top management. So this is the slide where Sanjeev had left. If we go back, what we basically argued was that as long as resources are getting allocated in a constrained environment, as long as they're allocated according to the critical path method, and this was the example plan that we used, this is how the work has to happen. So if we go by critical path logic, then we should, and there are only limited resources available, there are more work available than the resources. Under this condition, the critical path logic tells us to prioritize the most critical tasks, and therefore this is how it will get distributed.
Yeah, and this also relates a common convention that if work is available to start, it should be started.
It should be started. So get a head start on every work stream. And that is in some way that is intuitively correct also, because people know that there are delays and changes that are going to happen in the future. And so if I don't start now, if I start early, then I have more reaction time. If I don't start early, I have less reaction time. So that is probably what drives that behavior. And also the fact that if you just use critical path method, then it tells you should be working on whatever is critical first, and you should put the non-critical things later. And that also leads to the same answer, that you start on the critical ones. Since you have limited resources, you can only do limited amount of them, and you have to make a choice. And the problem we stated last day was, if we follow critical path method perfectly throughout the organization across different stakeholders, then this is what the picture will look like. But imagine if all of them are different entities, all of them have their own interests, and they're doing that allocation in their own ways, then the distribution won't even be this orderly. It's going to be much more chaotic. And whatever we do, we are going to end up with a bad answer, because that's the nature of NP-hard problems, which we discussed last day. And so what we proposed was that the problems that are coming because of these multiple things coming together. So this can be 2 drawings are required to make the 3rd drawing, or in civil works, we need to do piling. And in order to do pile caps, we need the piling to be done and the pile cap drawings also to be available. So wherever multiple things have to come together, that is the most risky place for resource shortage to hit. And that is what runs away, as we are also seeing in the after picture, that all the places where things have to come together are generally running away. This is the problem we wanted to avoid. And the proposal that we had was, since we cannot solve this problem, so we would rather avoid it altogether. We would not get into solving the problem. So then if we don't have to solve it, then we don't have to face the consequences of trying to do that. So the question is, how do we do that? And there what we showed last time is that if we create batches of work, which I'm going to show in the software, if we create batches of work and we don't bother about when is this drawing required, we just focus on the batch and close it and finish it and keep going ahead, then it leads to much better results. And how are we avoiding the problem? Is that if you look at the original network that I'm showing here, there are integration points that are running in parallel. We are just making sure they're consolidated into one. So in real terms, we are trying to solve the coordination problem, but by not trying to coordinate. So the first attempt is to minimize coordination requirements.
Yeah, can I just check something out for understanding there? That my interpretation is, it's not that somebody shouldn't worry about that integration.
Yeah.
The issue is that's not the job of the project manager and the project schedule. Yeah. That could and should be left within the remit of whoever's managing that particular grouping. So it still needs coordinating, but within the confines of the group of tasks or the larger work package. Is that reasonable interpretation?
That is a reasonable interpretation, yes.
Okay, so
in the picture above, this is left to the front line, because project management traditionally doesn't recognize this problem at all. The resource allocation is an issue. So it is left to the front line. And if it is just left to the judgment of everybody on the front line, then it's not controllable. But if we can give a logic, create the boxes or the batches on top, and then we are not trying to coordinate the front line. We're not trying to do the front line work. So front line still allocates resources, but inside the box.
Yeah, and the project management team. Yeah, the project management team focuses on the flow between the tier 1 boxes, but it still expects the tier 2 to be well managed. But you don't try and do it in one single scheduled and controlled environment. In effect, you're decoupling the work so that you reduce the noise that's seen at the project level, and when they see problems, they can be sure that it's a real problem, not just normal day-to-day variation and emergence. Good, thank you.
And the logic is, just to emphasize on your point, the logic is that inside the box, when you said it has to be managed well inside the box. I'm sorry. So it's not that the management is completely, we are depending on somebody to manage well. That's why the word focus and finish. So this tells us that in this batch, make sure it is sort of like an infinite resource situation inside the box. So across the project, we don't have enough resources. But if resources are enough for one box, so be it. That box should be without any resource constraint. So basically, we are still avoiding the problem. The problem comes when both the integration point and resource shortages hit us. So inside the box, there will be integration points, but we are not allowing the resource shortage to hit. So the problem should not arise. So we are, by doing this, we are enabling the frontline managers to actually be able to allocate resources very efficiently.
Yeah.
They don't have a shortage. They don't have to choose. They can just allocate their resources, whatever work is available.
Yeah, because there are simpler rules that they're using now. So
the moment resource limitation goes away, there is no choice to make. You just put your resources for whatever work is available. So there you can't go much wrong. I mean, you and I would probably do the same thing. Anybody would probably do the same thing. There's no different choice to make there. Okay. So we are removing the choices completely.
Thank you.
So this is basically the logic. Now, if we have to use a software to do this, we cannot use the traditional tools, because why? Because in this picture, the boxes need to be identified, the batches need to be identified. But in reality, work will actually get executed in the dots.
Yeah.
People can only identify dots. An engineer needs to know the name of the drawing. It doesn't care what the batch says. It still needs to identify which drawing has to be done. So the work will still happen in dots, which means that if we have to do this, then we need to build the network at the batch level. But when work is getting allocated and the priorities that are being driven by this batch level has to also flow to the dots, and people should be able to see dots when they're doing the work.
Yes.
Now, if we try to do that in traditional tools, if we define the dots, the network immediately goes to this level, which we sort of discussed last time. And if we only define the batches, then people can't see the dots. So yes. that is the problem. So
and in some environments, I assume there's an overlap, and I've seen it in conventional big project scheduling that actually the work that needs to be done at the dock level is actually embedded into some other workflow system. It's the knowledge management system of the project. It's where the data sheets are kept for each individual main plant item, and they're listed. And the one of the dot activities in the schedule looks at the knowledge management system and can see which of the data sheets or drawings have been approved so that they can start on. So one of the issues I've seen in large critical path and Primavera schedules is the schedulers write the same information in Primavera, but of course then keeping the two interfaced and interlocked and consistent is very different. And the people doing the work still look at the knowledge management database. The schedule is just full of detail for somebody else, rather than just let them get on with that work. They don't need telling which is the next approved drawing that they can work on, because that's already visible to them. They don't need the schedule to tell them that.
Exactly.
Yeah, and
they have the list of entire drawings. So there might be 10,000 drawings in a project. They have the list of entire drawings in their own system. They can see what is the available work. They will make a choice on their own. They are not going to look at a schedule to really decide. First of all, even if they look at the schedule, it's going to guide them in the wrong way. It's going to ask them to do the things that shouldn't be done. So it doesn't help. Two is changes will keep happening in projects, and changes are happening at the dot level. So this is continuously getting changed. So it's not like a constant reference even for me. If I want to look at it, today it says something, tomorrow it will say something else. But it's better to rely on my own judgment. I look at the work available. I know more or less which ones are more critical, and I take a decision according to that. Or I know the customer is chasing me for which drawing much more. So I will just allocate that. So that's a much easier thing to do. We will do this mapping. So in our case, we are saying that's why we need a different logic of building a network. And the software that I'm going to jump into right now is basically how you create a plan or a network. I won't use the word plan because it's used in different ways. The network at the batch level. And then it's a multi-tier network, which means that dots can go inside the batches. So we are still working in dots, but I know where the dots belong, which dots I have to do now, and which dots I cannot touch now, even if they're available. So that's one. There's another practical problem, which is even at the dot level, there are further levels below. So when you're saying mapping the MSP or Primavera plan with my knowledge center database where my list of drawings are, then also there is a mapping issue. And then with the MSP Primavera to the batch level, there is another mapping issue, because the batch level is still higher than this picture above. So this is the MSP Primavera plan. And below it, there is basically the list of knowledge center drawing lists, which have to be also attached to this. So basically there are multiple levels. So we also have multiple tiers. So even the second tier is slightly high level, not the absolute dot or the drawing number or the drawing name on which an engineer is going to work. So that's even a level below. And reporting of progress is also happening at that level. So people are saying, I have submitted this drawing. Or somebody is saying this drawing has been approved. But how does it link back to even the small set of drawings that we are talking about that has to be released to civil works? That is one problem. And then bringing it up to the batch level is another layer. So we have multiple tiers. Network always remains, unlike the traditional systems where the network goes down to the level of your definition. In this case, the network always remains at the box level. The details keep going inside the boxes. So just advice, I'll jump into the software.
Please carry on. And at the top box network level, that's where you have the logical dependencies between the boxes. So unlike using MS Project, Primavera, that requires you to put the dependencies at the lowest level of activity that you've put in your schedule.
Whatever you define, you go down there. This is sort of the starting point of the software, and we'll basically talk about two of these boxes. One is the project control room. which is going to talk about the visibility of this this map that we are focus and finish map that we are creating. And the other part is going to be task management, where how do people actually work on the dots, that is going to be demonstrated.
Okay, thanks.
So I'll start with this. And so basically when I get into a project control room, what the software does, it gives me a quick view of all the projects in my portfolio. So we will not go through all of them. So there are, what it shows in a snapshot is there are 21 projects in the portfolio.
Yeah.
And there's a color coding and there's a number, if you can see.
Yes.
So what the color coding basically tells us is if it's red, then it's telling us probably you can't get it back anymore. This project has gone too far out. If it's orange, then yes, it's gone far out, but probably you can take few key decisions and get it back. If it's yellow, don't worry about them. Site is managing it okay. If it's green, you're going ahead of time. Don't even think of them. So they're going fine.
Okay.
This is the primary differentiation. Then the 1, 2, 3, 4, 5 is the relative priorities of this.
Okay. And just quickly on the algorithm behind that, because our students will have come across the basic critical chain method, which realization started out using. Is that priority based mainly on project plus, or do you use other?
Yeah, so we use the same logic, but not the buffer based calculation. And that is because there is a lot of confusion about project buffer amongst people. So some want to keep a buffer, some don't want to keep a buffer. So we unified that rule by saying we are going to compare how much time is left in this project till the due date. Okay. And how much work is remaining. So we're going to compare these two.
Okay.
So if, for example, I have 6 months left, but I have 8 months of work balance, then I'm in a critical state.
Okay. But yes, you use that idea, but you keep it a step removed from the people looking at it. Good. Yeah. Thank you.
So accordingly, this 1, 2, 3, 4 comes, and this is obviously what the software is doing. And now we ask the question. So let's go to this cement plant example. It is saying that the due date is 31st August 2023, and right now the system is saying this project is going according to the map that you put in the system. It is going to 23rd December, and we would like to know why. Okay. So we can click on this. And it takes us, and what is it basically showing is the network that we created in the beginning. It is basically identifying all the different paths that network can create. You call it paths or chains, basically sequences that network has. And it's finding out which is the most critical sequence at this point in time. So just to be sure, we had started with a plan. At that time, the critical path might have been elsewhere. Yeah. And actions happened on it. Delays also happened on it. Uncertainties also came in. So based on all that, at this point in time, this is where we stand. So it's giving you a live picture of where you stand now, right now.
And can I just for our students who are new, my understanding is here you're showing your system in a swim lane display, which shows that you've just turned it on and off. The logical dependency. So it's a logically linked network displayed in swim lanes using different work streams. My understanding is the user can choose between sort of this mode and a more conventional Gantt if they prefer to see it that way.
Yeah. That is Gantt is always there. Yeah, of course. I will show you the Gantt also. The planner can also look at the Gantt and take decisions. But from a project management perspective, I would most people probably prefer this because it tells them where the problem is and what is the sequence. Yeah. So if I can see the sequence, then I know that I am here today. So this is today. I'm on this basic engineering of the pyro section at this point in time. After that, whatever is coming. So if I am delayed, I can probably do limited amount of things here because there's not much work remaining in this current task. Yeah. But I can look at the future. And standing today, I can take a call that, okay, if I'm too delayed, I cannot make up anywhere. I will start making up in 2023 April when I reach mechanical works. I am going to deploy more teams than I had planned. and crash the duration. So this gives me the future view, and I can plan the action proactively. So I have time till April or mid-March to make this happen, to mobilize these additional teams, get the contracts out, etc. And I can really act here. So it allows me to plan out my actions in the future. So
in terms of scheduling, you allow a rolling wave mindset. I assume that the details of your dots at tier 2 and tier 3 and tier 4 get put in as that becomes short term. You don't force people to put all that detail in 24 months in advance.
Right. So if you look at this picture, there are some icons alongside the boxes. Right. So there is an icon which looks like there's a plus icon, and there is a slightly different icon. So this icon tells you that there are no tasks below. So we have gone directly to the super dots, which is basically the tracking level. Or as you were saying, in my system, there are 10,000 drawings, of which this is pointing out a 50 of those lists. So there is, I don't care about what dependencies there are between those drawings, because you will manage it anyway. All we are ensuring is you have enough capacity of those 50 drawings. So I can go down there, or I can go down to the schedule level, which I will show. And in the future ones, which are very far out in the future, there are no signs, which means that right now they're empty shells. We have made a good enough estimate of the size of the box, but the details we don't even know now.
So
if
you
don't progress, we won't know.
You can put overall resources on, but you'll break it down as you get closer. Good. Thank you.
And so if I want to understand, this is the basic engineering of the Pyro section, which shows as to be the most critical batch of my project right now. Every other stream has also batches, but at the end you can see this green bar coming up, which is basically the feeding buffer, or how much cushion I have. So it tells me that if there are 2 basic engineering batches that I can see, maybe I need 20 engineers to do this to done, and I have only 11 today. So what the system is saying, you can afford to put all 11 here and allow this to wait, because there is some cushion. You can take advantage of that. So the first point to realize it, if instead of 20, I have 11 people, delays will happen. So I cannot get both of them done on time. I have to sacrifice something, but this tells you the minimum damage to your sacrifice. This is the logic for the minimum damage. So while you prioritize this, you waste or lose some of the feeding buffer. If you can get more engineers, that will hasten your project. If you can't, you probably are going to lose the feeding buffer.
Which
so that is what it's.
Which won't impact the end date, so you may as well.
Yes, so it gives you to fight another day. So that much breathing space it provides you. And if I go into detail, so if I want to understand, okay, it's saying basic engineering of Pyro section, and it's saying remaining duration is 47 days. How is it saying it? So I can get down to the details. And it just focuses on this task, that, okay, this is your task. And I'll explain this battery or cell symbol. And then I have this list inside, so I can drill down the list. And these are basically the list of drawings. I have put 5 here for an example, but you can relate it with the example that you are providing. In the knowledge center, there might be 500 drawings. But out of those 500, it's pointing out exactly which 5 you need to focus on right now. So don't look at 500, make a call on your own. In that 500, these are the 5 which have to go out. And you might have more steps to this. I have 2 steps. You submit and then you complete. Before you complete, there might be to and fro. It will, as long as completion is not marked, we will always assume it's still in the submission state. So it might be going to and fro. And in the submission, the to and fro is recorded by this R2, R1. So it has been submitted once and the date has been revised twice. So that's R2. Here, the date has been revised once. So that's only one revision. So it might be going back and forth.
So that is in effect a like a configurable Kanban, as you can see, move flowing through it. And the people working on this work package would input their progress here in the same way that you might with post-its on a visual Kanban.
And we can also pick up the data from there. So it doesn't require somebody to compulsorily put it here. If you are doing it in some other system, we'll pick up the data. The only mapping between the two is that when you're opening the system, you should know which are the ones which are priority for you, and not choose your priority by yourselves. Don't allocate by yourself. Just make sure there's the same priority. So we can send a signal to that system also to mark the priority, and we can take the feedback from that system as well. So this can be just connected. So technology has gone far ahead to make these things very easy. And what the system is basically doing is it's tracking each and every drawing that is required in this batch. And from the combined effect, it's figuring out that there's going to be 47 days more that are required in order to finish the entire batch. So we are not worried about individual drawings. Some will get done early, some will get done later. We don't care about individuals. We want to understand how long is this batch going to take. And if we can do something about reducing the timeline of the batch as a whole, then we would probably go and take an action at the micro level. But otherwise, this is just taking the daily progress from people, converting them into an impact on the total duration of the project. Then it's putting it back in the task. Then it is putting it back into the network. The network is recalculating, and it's telling you where your priorities lie. So this is the job of the system. And I'll take another example, can be a network inside also. Yeah, so this one, let's say we are looking at the civil works for preheater. So in this case, we can have a mini network inside, the type of networks that are there in Microsoft Project or Primavera. So this basically gives that how first we'll do the foundation, then we'll do the slab casting up to 12 meters and slab casting. So there are 4 slabs to be casted after foundation. And this is the dependency that the work will follow. So you can define a mini plan inside as well.
Yeah. So that's an example where at the within the box, the work package manager can use the format that they're familiar with, that's more suitable for their kind of work, that they can pick and mix as suits them. Yeah.
Yes. So this is like a local network inside the task.
Yeah. And if they use your technology, the roll up of the work package progress and prediction of when it will be finished is built in. If they use a different technology, you're developing the interfaces, and presumably if there's no interface, they can still manually take the output from their system to give the right information into yours.
Yes. So you can theoretically create this focus and finish level plan in a software like Primavera on MSP, and then have different files which exist for each of the tasks, where you can build your local schedules or you can build your progress reports. Yeah. But the only thing is you have to connect it back in that fashion. So the local schedule should be subordinated to one of the batches in your parent network.
Yeah.
It should not be across batches. Then you don't have a way of coming back. Just so that is one. Yeah. And two is, especially in cases of civil works or mechanical works where it's mostly a volume-based task, the reporting of work happens at a volume level as well. So if you look at foundations, it might get measured in terms of foundation number. It can also get measured in terms of excavation, PCC, how much shuttering is done and how much concreting is done. So in terms of quantities. So if it is in terms of quantities, as is the case here, so you can define a quantity below. You can, and the system will tell you that, okay, on the basis of the duration you're taking, this should be your plan rate. It should be 30 cubic meters a day. That is what you should be targeting. And then people can just report in a normal way. So people are very used to reporting how much progress happened today. So that's all. We are not asking for dates. We're not asking for commitment. Just tell me what you did today. On the basis of that, the system can figure out at what pace are you moving.
Yep.
And therefore it can figure out how much time it will take to complete the job.
Okay. And is this where you could incorporate other sort of detailed conventions, like here you in effect using a velocity expectation because there's 30 cubic meters a day and expected productivity. Can you build in some of the features of so-called location-based scheduling, where you're following a pipeline moving along?
Yes, yes, we can also do that. So there are 25 different formats which are already inbuilt. So you can track locations if you want. You can make this more complicated if you want. So there are basically 3 types. One is a date based, one is a volume based, and one is a location based. So there are 3, and then you can combine them together. So you can combine volume with location as well.
Okay.
So if you still want to track by location, but you want to report by volume. That's it.
Yeah, but
so
this
you
is
can also do those combinations.
Yeah, this it seems to me that this kind of detail is important for the people doing that work.
Absolutely.
And you separate, the overall project manager doesn't need to know, he just needs to know it's being done well.
Yes, yes.
Yeah,
absolutely.
good. Thank you.
And also they can make few mistakes from time to time. The only thing is, if the mistake is big enough, if the mistake is small, it doesn't hurt you. If the mistake is big enough, you get to know immediately that's a mistake. Somebody has reported, instead of 200, I put an additional 0, it becomes 2000. So that immediately shoots the picture above up, and the manager immediately asks what happened. So you can
Yes,
so
yes.
that is there. So the point is that at any point in time, we are not trying to really tell people at the lowest level how to do their job. So we are not trying to give them a detailed schedule. That's one. 2, we are not asking them to do calculations. You just report what you normally report. Our objective of the system is that I have communicated the scope to the lowest level below. We have agreed on a reasonable time that the scope should take. At that, and we have ensured that you have enough resources to do the job. Now, inside technically how you want to do what you want to do first, etc., your call. The only thing that the system is doing is trying to measure the pace at which you're going.
And if it's done well, and correct me if I'm wrong, if it's done well, you've kept the feedback very simple, available, but frequent. So, a supervisor on site will be keeping track of trucks coming in. They'll already know how many cubic meters they've poured that day. So it's not an extra burden of reporting. So expecting them to do that every day is easy, because reporting is often a problem because it's burdensome.
Yes. So just to be sure, yes, on one side you are correct that we are not asking them to do anything extra. In fact, they actually report the progress every day because it goes into billing. So whatever goes into billing, people do that religiously, right? Because at the end of the month, the bill is going to be generated on the basis of how much you did in the month. So they actually report on a daily basis or a weekly basis, how much concrete did I pour? That is the basis for my billing for concreting, because the BOQ item says I'm going to charge you X amount for concrete.
Yeah. So you've exploited that. They're already good at that. What they don't like is the monthly progress report.
Yes, they don't like that. Yeah. So that is one. But sometimes what happens is I am reporting for concreting across my site.
Yeah.
That doesn't help. So this breaks it up into some areas, not like 200 areas, but it breaks it into some areas that we don't need an aggregate reporting of how much concreting has been done across the site. That is not how much concreting has happened in this box. That's what we want to know. So that might be a slight departure from. So it's a departure in mapping. People usually maintain 100, 200 Excel sheets at sites. But the mapping of the Excel sheets might be different. So this might be less, and this obviously is less in number, but the mapping is different. So they might be combining areas according to their own will, but this reporting is driven from the top. So what I want to measure is what you report.
Yeah, got you.
So that is maintained by the system by making it come from the tier 1 level.
Thank you.
That is automatic. Okay. So this is how so the algorithms here basically look at your speed, whether it's a date based or it's a volume based or it's a location based way of reporting. What the system is trying to do is we are just trying to measure the speed, and we are trying to roll it back and tell you what is the impact on the tier 1 level task or the focus and finish level task. And then we just want to know what is happening to the map that we created so that we can know where to take actions.
Yeah.
So this is the primary reason. Now, so this is a direct sort of way to find out how to take my recovery actions. but there is a bigger purpose for this. So the basic premise of the logic is that when you have limited resources, you focus them on only the priority tasks. If you don't have any, so the basic logic is, as I said, I have 11 engineers, combined I need 20. So you don't need to do calculations. Make sure you put whatever you can on this. So let's say I can put 10, only one remains. Then you can choose. The one person can sit idle, or you can put him on this task and make some little bit of progress. It doesn't matter. But make sure you're not dividing them 5 and 5 or 5 and 6. Make sure this one is always loaded. So if that is being correctly done, then if there's a shortage, we should see good progress on the top priority task and maybe lower progress in the lower priority task, or the lower priority task might not even start. That's at a high level. That's the only way for me to know whether focus and finish is happening or not. And so the system provides you ways to test and see whether that is happening. So we can decide to highlight. So the system is continuously measuring the pace of the task. And I can ask the system to highlight if anything is stuck. And I can see that these two are stuck, which should ring the alarm bells for me, that if I am doing focus and finish, how come my most two important tasks are stuck? They're not moving. They are the ones that should be moving. I can expect to see stuck tasks below. I can see nothing is stuck below. The two most priority ones are stuck. So then I should be starting to doubt whether I'm really doing focus and finish on the ground or not. So it is not just about allocating resources, but also if there are resources that are facing any issues, management should be solving the issue at super fast pace.
Yeah,
and obviously that is not happening.
And that's a good link of the separation, because the project management is holding people accountable for the way they work, focus and finish. They're not holding them to account for an estimated date. That will be what it will be, providing you're working in the way. Now, another of the features of this, and I know early on you said you will only look at 2 boxes, but one of them I think would be very useful for our students to see, and it's the proactive idea of full kit, so that when a task arrives and the responsibility is passed to the next box, you know that the next box is ready to start. And that's about being proactive. This helps you react very quickly on the early signs of a problem. So could you show a couple of examples of how you've built in the idea of full kit management and being proactive to avoid obstacles in the future?
So as you said, there are 3 layers to my problem solving. So one is when I sit in the beginning of the project, things that I can see, I know about. So they are captured in tasks. So that is how the batches are created. So as you can see, the ordering of the cement mill, it is after the basic engineering of the grinding section. So this is, I can predict right from the beginning that it is going to happen after I complete the basic engineering. So that is mapped in my in the logic of my batch network. So that is one. Then comes things I only get to know when I get closer to the job. So when I'm 1 month before or 2 months before, I get to know of real ground realities. I get to know about them, and I should be mitigating those risks. So for that, there is the full kit. So I can do a show full kit, which brings out this battery sign. And so this is basically the list for this box, that what are the things I need to take care before I start this, in addition to the dependencies which are there, that will prevent further problems from coming up. So if I go into them, I can maintain a list. I can plan out all the things I do. So what this says, that there's some basic parameter finalization which should happen, some efficiency calculation should have happened, and some layout and load data should have come from someone. So are these things in place? And the red color and the why it says poor is it saying that after starting the task, the full kit items would be completed way after you have started the task, based on the progress in the full kits, which is not the right thing to happen. You should have the full kit completed before you start it. So it's basically tracking and telling you how late your full kit is going to be. So that is an indication of whether you are going to face problems during execution or not. So this is the full kit part.
Okay, yeah.
And then there's a third layer. Even after capturing your known dependencies in the network, even after doing good full kitting, you can still face some problems while you're executing. You cannot remove the possibility of that happening.
Yeah.
So in that case, the user can, in this example, there are no such icons visible, but the user can raise runtime issues immediately. And I will show you when I get to the user part. They can raise runtime issues that I have faced this problem. I have excavated somewhere and there is a lot of water coming out. Now I need a dewatering system immediately. Otherwise I cannot proceed. Yeah. And that request has to be granted by somebody higher up. So the person can escalate the issue right there. And the person higher up might be getting 200 such issues from all over the site. But the system gives the person the issues in the priority of the work. So whatever is coming from the super critical task, you should do them fast. Whatever is coming from the green task, you can postpone them if you don't have enough bandwidth with you. So this is the three-pronged approach to basically handling delays and changes.
Okay, so you have some workflow and flagging up of that sort of out of the original plan change management and
yes,
that flags up the priorities for the change management system related to actual progress on individual work packages and projects. So it allows a tie-in and a prioritization. That's because in my experience, those two things are separate, and therefore, if you do have a backlog in approved changes, then it would have to be people talking and arguing which order to do them.
Yeah.
Okay.
So everybody start to just one logic, which is the priority of our map that we create together. So that's like the single version of truth for everyone. It's a common platform on which everybody is existing. So my full kitting, my issue resolution, everything is coming from just one prioritization system, so that I don't have I'm not trying to manage coordination at all. The system, whatever remaining coordination is there apart from what we took care by consolidating all this integration points, whatever remaining coordination there is driven by the map purely. So it's not a human driven system. So this is the top management perspective. They can also take a look at the project in different ways. So sometimes they might, so this is now, it's just convenience that, okay, I don't want to look at my entire project plan, because sometimes big projects can have big networks. So I don't want to just look at my entire project plan. I want to, let's say it's a power plant project. I want to understand what is happening to my turbine. So those are convenience pieces. You can select any task and you can say, just show me, just show me the piece of the network that's related to this task. So the system quickly tells you, okay, this is your network. The task that you chose, which is the bucket elevator connection and preheater completion, only the scope for only that is this much. And these are the relative priorities on which your work lies. So this is all convenience if you want to see the project piece by piece. Or sometimes there are different departments who are doing different parts of the project and they want to take a look at their own part. So this is how, but the priorities are always aligned. So it doesn't ever change the priorities for all. So this is not saying 1, 2, 3, 4. It's saying 1, 4, 6, and 9. This is your relative priority to the overall project. So you should expect support in that priority as well.
Okay. And presumably for resource team leaders who have large specialized resources that work across many projects, they have a similar view that prioritizes at the box level.
Yes.
So that they don't need asking by a project manager. They can see where they should be prioritizing their limited resource team as well.
Yeah, and that comes under task management. So there is this one manager called Manoj Kumar who has been chosen, and this is his own screen. So he opens his screen. He is not working in one project. As you can see, he's got a project from process building. He's got a task from some other project, chemical plant, then real estate housing, then solar plant. So this person is the department head. He can see his entire portfolio and whatever task is coming to him.
Good.
So in that case, also they're prioritized across projects. So if he has to allocate resources, he knows where to do it. So it's not project specific, it's across project. So this is basically how we are communicating to the department heads.
Okay. And if it's a single resource, then they just work on the first one, focus and finish, then the second.
One rule. Yeah.
If it's a team manager, they just make sure that they're whatever size their team is working these priorities.
Yeah. So load here, if you have balance, load here. If you have balance, load here. When you run out, just leave it.
Yep. They have to wait. Good. Thank you.
And here you can see this wrench symbol, hand holding a wrench, and the one written here. This is basically a runtime issue has come up. So you can basically go to the runtime issue and you can see that, okay, the runtime issue is 10mm steel is not available.
Okay, right. So that's part of the reporting that open work package managers are expected to report at whatever cadence and frequency, and presumably in line with one of the critical chain philosophies of frequent, easy feedback, so that your progress is if not in real time, it's very close to real time. Presumably you have features built in to make that reporting easy and simple, do you?
So there's only one input which they're putting, basically how much work I did today. Apart from that, if they have to raise issues, they're raising issues. The system is arranging all of that. We are trying to give a feedback to everyone. So at the task manager level, the duration feedback is real time. So if this is showing 191 days, this is real time. The moment somebody makes an update, I would be able to see 191, whether it changed, whether it increased or whether it went down. That is real time. If I go down below to the subtask manager level, so you can keep distributing the work in the system. So the Manoj Kumar can assign 2 managers who are different, and they will see only their subtask in the system.
Yeah.
So here also, so task down, everything is real time. It's only the priority of the batches which are overnight. So whatever inputs we got today, tomorrow the priority might get revised based on the inputs. So that is only overnight. Everything else is real time. So you get to know the duration change in real time. As soon as somebody reports, you get to know. And below also it's real time. And the feedback is you get to see whether you're following the focus and finish logic, where you're able to do the full kitting in the right way. Are you able to meet the duration? So all these things you get to know. So this is real-time feedback. At the levels below, it's also real time. So when somebody gets the information of what is my foundation work, how is it moving, what was my planned rate, how am I progressing right now? So it's clear that my planned rate is 4 cubic meters a day. I am going at 1, so I'm definitely going behind, and I need to catch up. So that is also real-time feedback. Based on whatever data you put, system tells you immediately whether you are catching up, whether you are going slower, how long are you going to take if you go at this rate. And you can do also what if to understand whether I can, how much do I need to do in order to make up. So all those things you can do. So that's all feedback to the people. So the job of the department head is to also maintain the sanctity of the system, to make sure that this is not the picture. You should not have a red full kit for the most important task of your system, then it's going wrong. You should be talking to the full kit manager as to why this is not closing. Similarly, if you want to see the top task, it's showing it's stuck. So it gives you immediate feedback that this is the most important task in your portfolio. It is stuck. It should not be. This one should be moving. You can have stucks in green, that is fine. But your top priority task should not be stuck. So it's a feedback whether you are being able to follow focus and finish or not. So at every level, you have the option of taking actions in your sphere of influence.
And if your project was simpler at the box level, and you didn't have a system breakdown of work, so your software couldn't work out trajectories and use the algorithms to work out when it would be finished. Can that data be manually be put in like a more conventional critical chain? Do you still have an expected finish based on current work?
Yeah. So earlier we used to use just a very rudimentary system, which was only at this level, at the tier 1 level.
Yeah.
And we didn't have all this conveniences below and all these algorithms figuring out speeds, etc. It is just a matter of a lot of discipline. So our people used to do that. We used to maintain all the Excel sheets. We used to collect the progress and then figure out what is the rate at which you. So logic remains the same. Yeah. It used to get done manually. It just takes more time and it is prone to errors. So that is the only thing. Yeah. But obviously, the logic, it can be done manually. It doesn't need to be automated.
I was probably thinking of the sort of smaller scale work package that's still important, where the people doing it, they do have a reasonable intuitive, I think there's 8 days work, no longer 5. The more textbook critical chain input is when will we be finished? So you can that's where you started, you say, and
absolutely. So for a simpler project, you can just have a whiteboard where you have just drawn the map, and you just keep reducing durations on the whiteboard. That also works.
Okay,
because it's possible to get that visibility in a very small space. So and of course work there.
Good. So your particular system is designed to scale for sort of small, lightly managed projects, as well as the very large engineering ones with lots of important detail to manage.
Yes, and where the tasks might be, the chunks or the batches might be a little too big to make a very quick assessment. You need to know some details in order to make that assessment. So there, the system, the algorithms help in doing that. But as you said, if it's a simpler project, probably the person who is doing it knows whether it's 6 days or 8 days. They might be wrong by 1 or 2 days, but it doesn't matter.
It's better than nothing.
That's not.
Okay.
The focus, just to be sure, is never on accuracy. So, and this is an important point I think we need to make, because this is a discussion that we get in again and again with the customers, is that when we are looking at the projects, whether this is 2nd June or whether this is 26th May or whether this is 14th June is really not the point. Because standing today, whatever I'm saying, it is an estimate. So there is nothing correct or wrong about it. What is important is what is it relative to the other projects. That is important. And we are doing it by the trend. So, and I forgot to show you this. So for us, what is the most important thing to understand in a project are these 2 pictures. So without getting into details, we want to get to these 2 pictures. So we are not trying to say that 23rd December 23 is the perfect answer. So we are not targeting accuracy. That was the entire focus of Sanjeev's presentation, that we are not trying to optimize for accuracy. What we are looking at really is this 23rd December 23, is it moving out or is it coming in? So this is what the trend tells us, that it is flat. If it is flat, then we are pretty confident that we have it in control. It's not slipping away. And we can, when we are closer, we can find a way to crawl back.
Okay.
So if it is going down, then we are coming back. We are very confident. But we should be alarmed that even if the delay is 2 days, we should be alarmed if the trend is going upwards, which means we are just, it's like looking at Google Maps and you are traveling and the remaining time is just increasing all the time. So then I'm not going to reach to do the meeting on time. So that is the situation that we are trying to avoid.
Okay.
When we're looking at the work stream trend, so this timeline trend is derived from whatever is the topmost sequence. But when we look at the work stream trend, what it is doing, it is looking at all the sequences. And you're saying you started with some colors. Is the trend worsening? Is the proportion of reds increasing? Then you should be worried that you are losing the rest of the project slowly. So these are the 2 most telling signs whether you have the project under control or you are losing control. So we are not worried about the accuracy of the answer. We are not worried about exactly what the value is. We are worried about the trends.
That's consistent with some of the sort of underpinning theories that we're encouraging our students to think about, because project work it's not complicated, deterministic and repeatable. It is complex and unknowable and emergent. And the key thing is not trying to force a project by more planning. It's to allow it to do what it will do, but notice the problems, but not to act on just the normal variation. I think, that's why I see the conventional critical chain fever chart as very similar to the manufacturing SPC control chart. So any movement in the yellow band is normal. Don't act on it. You act when you go beyond the SPC control levels. And that's a feature of, I think, of any good control system is separating the signal from the noise. But we want the good early reliable signal that there's a problem, and avoid the project management convention of managers only discover problems when they're enormous.
Yes, of course. There are hundreds of problems every day. As you said, it's an imperfect world, so we cannot expect perfection there. So sorry, there are hundreds of problems every day, and it's impossible to solve all of them. So the point is, which ones do I solve? And ones which are causing my trend to go bad are the ones I solve.
Yeah, and if you've got a good project team, that's their job. Their job is to solve. Absolutely. If you're relying on the project manager or the senior executive teams, your problem is not one of scheduling. Your problem is one of organization, delegation, and management and skills. Absolutely. A better schedule won't fix that underlying capability problem.
Yeah, it can't.
No, that's good. But thanks very much for that very comprehensive and detailed overview, Sourav. Are there any particular sort of features and aspects that we've not tripped up over or come across yet that you think will be helpful for our students to get this match between what flow-based scheduling looks like once built into scheduling and control technology?
Not much. This is how it looks like. This is how we identify flows of work. This is how we prioritize them. This is how we apply, focus, and finish. So that is the more or less the nutshell. In a nutshell, this is the story. The only thing that we have left out is we still need to measure. We need to have some matrix as to how are we doing in terms of following focus and finish. And there needs to be some measure because there are contractors involved. Their performance is to be measured. Their internal management teams whose performance need to be measured. And not from the perspective of penalizing them, but from the perspective of understanding where organizationally, where I'm weak. Yes. So for that, there is a feedback system which is separate. Which is very simple. There is only one principle on which we are working on, which is focus and finish. So the idea is, if you are taking up a task, you should be able to do it quickly, right? And because you are supposed to allocate your resources to a priority task and get it done quickly, the system automatically measures that on an average, if you have handled more than, let's say you have handled 20 high priority tasks have come to your plate, over the last 6 months, what is your average deviation from it? So if it is in a small range, it's not a problem. But if it is huge, that your top priority tasks as a rule or as a convention tend to take way longer than it's planned for, then probably resource concentration is not happening or issue resolution is not happening in your area. So that is a cause of concern. So the system also provides you a feedback at an organizational level, that how are you doing it? How are you following the basic logic? Is your cycle time performance good? Is your full kit compliance good? When issues are raised to you and they're from red task, what is your response time? Is it good? So these are basically the three parameters on which the system tries to understand whether organizations are doing okay.
Okay. And do you do you allow capture at the sort of project level or the lower level of or the manual input of, you know, where am I stuck? I know you showed that tasks are stuck, but are you gathering the range of continuous improvement data so that even at the project level, a project can identify you know, a Pareto and then prioritize some sort of management intervention to the biggest causes? And as you say, some measures the system can calculate automatically, but do you bring in manual continuous?
Yeah, so the raising of issues is given because of that reason.
Okay, that
when you raise an issue, you have, so let me just quickly show. So I can raise an issue from anywhere. So I can raise an issue from deep down inside the task, or I can just select and say that I want to raise an issue. So when I raise an issue, I have an option to put some types.
Okay.
And I can pre-design it. So the system can aggregate them and tell you, okay, this is the reason why most of the issues are getting raised. But if people are not raising issues, then obviously we cannot identify. But we can still identify whether a task duration is getting stuck. It is not decreasing. So we can still highlight it stuck, but we can't tell you the reason for it if there is no issue which has been found.
And that helps management to see that there's still a gap, because this kind of focus and finish flow-based scheduling relies on the teams having the right sort of culture and trust and psychological safety, and it needs the management intervention to help people realize you're not going to get blamed, you're not going to get beaten up, but you are going to be managed. And if you're not sharing information, that's a bigger problem than missing an estimate. But at least
it is tough also. It is tough also because see, what we are saying is at a very fundamental level, again, going back to what Sanjeev, the point Sanjeev made, that you are thinking you're optimizing all the time, right, on the ground, but actually it's detrimental. It is causing a lot of chaos to your project. So don't do it. We already have the near optimal picture in front of you, just follow it. Now, for me, if I'm practicing this for the last 30 years, the moment I see a delay, my immediate reaction is that this piece I will do now, this piece I will do later, I will do some prioritization, rejigging, and I will solve the problem. That is my primary reaction to it. And I am always tempted to do that. It's very difficult to not do it. Yes. So that will cause people in the beginning to continuously, whenever they see a delay here, to challenge it and try some rejigging to make it up.
Yeah.
Right? And so we need the buy-in right at the top. And they should be driving, forget about it, just focus and finish the job. So not everybody needs to learn the logic, but the top needs to be very solid on this understanding.
No, they may not need the logic, but they need to believe that that the senior management really wants this. They're not just saying it because people understandably have got work habits.
Absolutely.
And if their habits need changing, then that needs to be done in an open, trusting, supportive way, or else people, certainly in the construction field, their habits have been keep your head down, don't say anything, or else you'll get in trouble.
So people know that this is going to get highlighted anyway. After a while, people figure out that the system highlights it anyway. If I don't report, it highlights. If I report and I hide, it highlights. So it is not like today I reported something wrong and got away with it because there's a trend. And it gets caught in the trend that even if you tamper. So those things slowly move away. People start appreciating the transparency. But till there is a period, as you are saying, there is a period where it's difficult because this level of transparency is not there traditionally. As you are saying, in my system of 10,000 drawings, what is happening where, nobody can really question it. And maybe 6 months later, somebody might say, okay, why aren't these drawings there? And we can have a fight on that day, but normally people don't question it. In this case, on a daily basis, it gets highlighted that this is not getting done. And that is a little disconcerting for people in the beginning. Yeah. So management, again, the top management has to be brought in.
Yeah, exactly. They will be looking to see whether managers are really changing and managing differently. Because if they don't, even the best system in the world will not make any difference. It needs, they're both prerequisites, it seems to me, the management environment and culture, as well as the technology to help facilitate that at scale. And you will have seen it, no doubt, like me, because in projects that have shifted even to the textbook critical chain, what I've seen is that the improvements that they talk about are actually around collaborative working. They've acted sooner, they've solved a problem that's been troubling people, they've come up with better ideas, and so it's that creative work of a team that's delivered the benefit, and the sort of the system is just part of the prerequisite, because it embeds that collaborative mindset in day-to-day work. But if the management isn't there, then it won't work on it.
And the predictability helps even in critical chain. When the best implementations that you take, it is the predictability which allows you to collaborate on the right problems. Because when you can trust the prediction that this is where I'm going to get into trouble, then collaborating is easy. When that is, predictability is not there, then on what basis do you collaborate? You can collaborate on a random problem, but that's not going to give you any benefit. So probably predictability of the system becomes very important when I'm trying to get people together to solve a problem, and all of them are feeling that this problem is really important, that we need to solve them together. But yeah, so that plays a role. And as you said, if we can get people to collaborate and solve problems and get progress done, then probably that's the easiest implementations are those where we have got solid management buy-in right in the beginning. Then it's almost like sitting back and watching, because they're just doing things and it gets done very smoothly. And the toughest ones are where we are struggling with that buy-in all the time.
And that I think is a great place to stop. That message about projects, the things we should be done are simple to understand,
yes,
but not necessarily easy to implement, particularly when we're working in a domain with lots of bad habits built up over time. Brilliant. Well, thank you very much for sharing.
Thanks a lot for
your
having
time
me.
with us, Sourav, to take our students what focus and finish flow-based scheduling looks like at a detailed level of scheduling control on a project. Brilliant. Have a great day and upcoming weekend.
You too. Thanks a lot. Yeah.